Hello everyone. I'm here to discuss the introduction to our subject, no, fluid mechanics. It is the study of fluids either in motion or at rest, no. So this is fluid mechanics. So we are to study fluids either in motion, no. So fluids in motion, no, movement of fluid, and what we call that fluid dynamics, no. Or at rest, we call it as fluid statics. So let's say we have stagnant water, so that is considered fluid statics, no? Okay, so let's first identify the classification of fluids. So there are different types of fluids. We have the first one is liquid, the second one is gas, no? And fluids are substances that are capable of flowing and conform to the shape of a vessel. No? So, so either liquid or gas. No? So these are substances that are capable of flowing, no? And conform to the shape of a vessel. So yung isang lalagyan, so kung liquid yan, so pagka ilagay mo sa isang container, okay, kung ano yung shape ng container na yon, gagayahin niya. Okay? So, yung gas naman, pagka tinakpan mo yon, tinakpan mo yung vessel, may matatrap na gas at yung gas na yon, okay? So, nandun lang, no? Sa container na yon, no? So, yung gas ay i-occupy yung buong volume na nasa loob ng vessel. Okay? So, there are categories or types of fluid. So, we have the first one, we have the ideal fluid. The second one is real fluid. Okay? So, we'll talk about that in detail pag nakarating tayo sa chapter, sa module 3, no? So, types of real fluids, no? So, we have Newtonian fluids and non-Newtonian fluids, no? Okay, just to give you an idea kung ano yung types of real fluids. So although in this module we will not talk about in detail about those, no? So we have types of non-Newtonian fluids, and namely we have pseudoplastic fluids, dilatant fluids, Bingham fluids. Okay? So minsan kasi sa board exam lumilitaw yung mga yan, no? So dapat familiar din kayo sa mga iba't ibang klase ng fluids baka lumitaw sa board exam, no? So we have dimensions and units. So when we talk about dimension, it is the measure by which a physical variable is expressed quantitatively, no? So ang tawag natin doon ay dimension, no? Measure by which a physical variable is expressed quantitatively, no? So ano ba yung example niyan? So later meron akong example. Pag sinabi naman nating unit, it is a particular way of attaching a number to the quantitative dimension. Okay? So to give you an idea, let's say we have dimension of length, dimension of time, no? So yun yun, no? Length, time, no? To name a few. Okay? And there is a corresponding unit for that dimension. Okay? Kasi ang dimension is the measure, no? By which a physical variable is expressed quantitatively. So, meron kang variable dito that is expressed quantitatively. Okay? So, example, no? So, let's say we have dimension. An example of that is length. Okay? and length is your dimension. And a physical variable we are to uh, consider, no? It is the measure by which a physical variable is expressed quantitatively. Okay? So, ang dimension may kinalaman sa physical variable. Let's say, ang ating dimensional length, the physical variable is distance. Diba? So, ang distance, merong corresponding length dyan, no? Length of travel, right? So, that's the dimension, no? Considered, no? So, we are to express this quantitatively, no? Okay? So, and we have another example of length. Magnitude of displacement, no? Magnitude of displacement. So, distance and displacement, may pagkakaiba yan. Distance is a scalar quantity. Displacement is a vector quantity. So, we only consider the magnitude of the displacement. Again, in physics, pag sinabi nating scalar quantity, no? It is a physical quantity that has magnitude but no direction. Pag sinabi naman natin vector, it is a physical quantity that has both magnitude and direction. No? So in this case, the magnitude of the displacement, okay, has something to do with length. No? Okay? So, distance. So, pag distance, may isip natin number. Kaya, it is expressed quantitatively. Magnitude of displacement, number ulit. Okay? A physical variable is expressed quantitatively. Okay? Another, no? Width. Okay? Width is a physical variable. Okay? So, yung width na yan, meron din length. Right? Okay? So, yung width na yan, meron ding haba. Okay? So, there is now a number corresponding to the width, no? So, kulang lang dito ay unit, right? So, another, deflection. Okay? Then deflect. Pag, o kaya, nag-deflect siya to the right, to the left. So, i-measure natin yon. Deflection. Okay? O kaya, bumaba, nag-deflect. Okay? So, yung deflection na yon ay i-measure natin. Okay? Height. So height can also be measured, and it is considered dimension of length, right? Height. Okay? And in this case, we will consider a unit to that, not to each physical variable. So the unit can be expressed in centimeter, no? Let's say 25 centimeter distance, or it can also be expressed in inch. Let's say 1 inch width. Okay? So, and many more units, no? Okay? So, we have 4 primary or basic dimensions to consider. The first is the mass. The second is the length. The third is time. The fourth is temperature. So, remember these 4 dimensions, 4 basic dimensions: mass, length, time, and temperature. Okay? So, because we have secondary dimensions na kung saan yung mga secondary dimensions gumagamit ng mga primary dimensions. Okay? So, later I'll give you an example to that. So, this is the primary dimension. We have this table. Mass is a primary dimension denoted by M. Length is a primary dimension denoted by L. Time is a primary dimension denoted by T. Temperature is a primary dimension denoted by the Greek capital letter theta, no? Greek capital letter or uppercase theta. Then SI unit, okay? So we have SI and BG unit. What are those? When we talk about SI unit, this is international system, no? International system unit. BG unit, British gravitational unit. Okay? So SI international system, BG is British gravitational. Okay? So we will consider here two types of units, no? So we have kilogram is an SI unit, meter is an SI unit, second is an SI unit, Kelvin is also an SI unit, no? Okay? So then we have the British gravitational unit, makes use of slug, foot, second, and Rankine. That's it, no? Alright, so we continue, no? So we have dimensions associated with common physical quantities. So as you notice here in this table, we have the FLT system and MLT system. So take note, F here is makes use of force. F is force. Okay? Let's say the unit of, we know the unit of force can be in Newton, no? It can be in pounds, no? So force is a secondary dimension. Okay? Force is a secondary dimension. Diba ang force ay, diba F equals ma? Diba? F equals mass times acceleration. Ang mass ay kilogram, which is the primary dimension. Acceleration, combination ng length and time, meter per second squared. So, length and time, tapos yung kanyang mass, kilogram, which is mass. So, we have mass, length, and time. Gumagamit ng mass, length, and time. Okay? So, kilogram, mass yon. Then, meter per second squared. Meter, yung meter ay length. Then, second squared ay time. So, therefore, ang force ay considered na secondary unit. No? Okay, so acceleration. So, in terms of FLT system, no? Making use of force, length, and time, we have LT negative 2. Okay, acceleration, length, no? Pwedeng meter. Second, negative 2. So, meter per second squared. Sabihin yan, no? Meter per second squared. Tapos, MLT system, okay? Acceleration, LT negative 2. Ganun din, no? Makes use of, ito namang M ay mass, length, and time. So, dimension na gumagamit ng mass, length, and time. So, in this case, pareho yung sa FLT system tsaka MLT kasi gumagamit lang pareho yung acceleration. Gumagamit lang yung acceleration ng length and time. So, pareho sila, yung FLT and MLT systems. Angle, ang angle ay radian. Pag sinabing radian, unitless, walang unit. Kaya F to the 0, L to the 0, T to the 0, M to the 0, L to the 0, T to the 0. Okay? Walang unit. Angular acceleration, that is radian per second squared. So, kaya kung mapapansin mo, T negative 2. Sabihin niyan, kung ang time ko ay second, second to the negative 2, that is per second, no? So, radian per second squared. Automatic, kapag unitless, we consider it to be radian, no? So, sabihin yung numerator ay walang unit, No? Yung denominator nun may unit. So, pag binaba natin to, yung T negative 2, magiging unitless over T squared, di ba? No unit over T squared. So, sabihin yan, radian per second squared, halimbawa. No? And many more. Okay? So, don't worry, yung mga terms na to, yung iba dito, gagamitin natin sa subject. So, hindi ko muna i-discuss to in detail, no? So, we consider other secondary dimensions. We have area, making use of length, L squared. Volume, length again, no? Kaya merong SI unit na square meter. British gravitational unit na square foot, no? L cube, cubic meter, cubic foot. Tapos, ito yung mga conversion factor na kailangan nyong tandaan, no? Ayan, dapat nyong tandaan yan. Acceleration, meter per second squared, feet per second squared, no? Okay? Tapos ito yung mga corresponding conversion factor, no? So, I will not discuss this in detail. Pag nag-solve tayo ng problem, ma-apply natin yan, yung mga conversion na yan. So, note that for every Newton, that is 1 kilogram meter per second squared, 1 pound or 1 pound force. So, as you notice, binigyan ko siya ng subscript na F, no? Denoting that force siya. Okay? Kasi, ang pound pwede ding maging mass, case-to-case basis. Okay? Pwede rin niya maging mass. Okay? Pag sinabi nating pounds na walang subscript, understood na force yan. So, 1 pound, that is 1 pound force, equal to 1 slug feet per second square. I'm encouraging you to memorize. Okay? So, 1 slug feet per second squared. Ang slug ay unit of mass. Okay? In BG unit to BG unit. Okay? So, then 1 Newton is 0.2248 pounds. Remember this conversion. For every Newton, there is 0.2248 pounds. For every slug, there are 32.174 lbm, pound mass. So dito, dahil ang slug ay mass, okay, therefore, ang pound na to, ang lb na to, lalagyan natin ng subscript na m, denoting that it is a mass. Okay? Ito ay mass. So, 32.174 pound mass is equal to 1 slug. Then, in physics, these were discussed to you, if I'm not mistaken. Prefixes for SI units. Factor by which unit is multiplied. No? Prefix, peta, alam nyo na yan. 10 to the 12, tera, 10 to the 9, giga, 10 to the 6, mega, etc. Okay? So, alright. Then, let's now proceed to properties of fluid. So, the properties that we're going to study here are as follows. Density, specific volume, specific or unit weight, specific gravity, surface tension, capillarity, compressibility, and viscosity. Okay? So, we first proceed with density. So, when we talk about density, the density of a fluid designated by the Greek symbol ρ is defined as its mass per unit volume. So, mass per unit volume. Ganun lang ang density. The density is typically used to characterize the mass of a fluid system. Okay? In the BG system, ρ has units of slugs per cubic foot, and in SI, the units are kilogram per cubic meter. So, ito yung ating density formula, mass over volume. The density of water is 1,000 kg per cubic meter. Okay? Remember this, that alam natin yung density is a ratio of mass of the substance to volume, to its volume, no? So, pag nagkaroon tayo ng problem solving, ma-appreciate nyo yung formula na yan. So, the density of water is 1,000 kilogram per cubic meter. Ibig sabihin niyan, merong 1,000 kilo sa bawat 1 cubic meter na tubig. So, ibig sabihin niyan, pag sinabi natin 1 cubic meter, that is about 1,000 liters. 1,000 litrong tubig katumbas ay 1,000 kilo. Okay? This is the standard density of water. Standard yan. Rho equals to 1,000 kilogram per cubic meter. Rho equals to 1 gram per cubic centimeter. Okay? Rho equals to 1 gram per cc. 1 gram per ml. Pare-pareho lang yan. Remember that. 1 kilogram per liter. Ayan. 1 litrong tubig, 1 kilong tubig. No? 1 litro, katumbas ay 1 kilo. No? Ito yung standard. No? Ito yung standard density ng tubig. No? Okay? 1.94 slug per cubic foot naman siya. Sa BG unit, 1.94 slug per cubic foot. At kung mapapansin nyo yung graph, kinukumpara dito yung pagbabago ng temperatura sa density ng liquid, which is water. Density of water as a function of temperature. Relationship na nag-e-exist between temperature and density of water. So, what have you noticed here? An increase in temperature habang yung temperatura ay nag-i-increase, nagkakaroon ng pagbabago sa density ng tubig. Bumababa yung kanyang density. Ibig sabihin niyan, nagiging magaan siya habang tumataas yung temperature. No? Nagiging magaan siya, no? Kada cubic meter. Kasi initially, at 4 degrees Celsius, malamig na temperatura yan. Yan ang standard na gagamitin natin. At 4 degrees Celsius, ang temperatura ng tubig ay 1,000 kilo kada cubic meter. No? Yan ang standard. At habang yung temperature ay nag-i-increase, nagkakaroon ng pagbabago sa kanyang density. From 1,000, okay, kung 100 degrees Celsius yan, ibig sabihin, below 960 kilogram per cubic meter. Mainit na tubig, kumukulong tubig na to. So, sabihin niyan, gumaan. Ang 1 cubic meter, 960 na lang. Below 960 na. Okay? At 100 degrees Celsius. Okay? Okay, so yan ang kanyang characteristic ng tubig. Habang umiinit yung tubig, nagkakaroon ng pagbaba sa kanyang density. Okay? Same as yung other liquids, no? Like oil. Okay? So, yun yan. So, density of an ideal gas naman ang ating pag-usapan. So, pag sinabi nating density of an ideal gas, we know that gases are highly compressible in comparison to liquids. Okay? Actually, yung ideal gas, naaral nyo na yan sa thermodynamics, right? Ideal gas. Kaya meron kang tinatawag na ideal gas equation. Okay? Ideal gas equation. Okay? So, they are highly compressible in comparison to liquids. Madaling makompress yung gas. Let's say meron kang balloon. No? Kung meron kang balloon, hipan mo ng hangin, madali mong makompress. Okay? Mag-exert ka ng force, nadideform easily yung balloon, di ba? Nadideform. Okay? So, unlike sa tubig, kung tubig yung laman ng balloon, medyo mahirap kumpara kung gas yun. Medyo mahirap i-compress. They are highly compressible, in comparison to liquids. Okay? So, with changes in gas density, directly related to changes in pressure. So, kapag nagkaroon daw ng pagbabago sa density ng gas, nagbabago din yung pressure tsaka temperature through this equation. Okay? So, ang density ng gas, ng ideal gas, may kinalaman sa pressure and temperature. Okay? Ito yung R na yan ay gas constant ng ating ideal gas. No? Gas constant yan. So the density of an ideal gas can be obtained by dividing the pressure to the product of the gas constant R and the absolute temperature. So yung T na yan ay absolute temperature either expressed in Kelvin or degree Rankine. Okay? This is the ideal gas equation. Ideal gas equation to. No? So, ang rho na yan ay mass over volume. Right? So, ang rho na yan ay mass over volume. Kaya meron kang PV MRT. PV equals MRT. So, ang PV equals MRT, yun yung ideal gas equation. No? So, ibig sabihin yan, rho equals P over RT, na-derive lang yon sa PV equals MRT. Yung ideal gas equation. So, we have density equals mass over volume. Yun isang formula. Another formula, density equals P over RT. So, pagka may example tayo, pag-usapan natin yan in detail, no? So, where P is the absolute pressure, rho is the density, T is the absolute temperature, and R is a gas constant. So, absolute pressure, naaral nyo na yan sa thermodynamics if I'm not mistaken. Absolute temperature, okay, and the gas constant. Okay? So, I repeat. Okay, yung ideal gas equation na PV equals MRT, no? Na-derive natin yung rho equals P over RT, which is also another form of an ideal gas equation. Okay? So, that's it. Then, let's go to specific volume. The specific volume is obtained by dividing, by getting the ratio of the density. Or reciprocal pala, I mean. By getting the reciprocal of the density. So, 1 over rho. 1 over density is specific volume. Okay? So, specific volume is the volume per unit mass V over M. V over M yan. Volume per unit mass. Or 1 over density. And is therefore the reciprocal of the density. Okay? So, note lang that the density has a unit in cubic per kilogram or cubic meter per kilogram or cubic foot per slab. So, yun ang specific volume. Unit ng specific volume, no? Specific volume unit, cubic meter per kilogram or cubic foot per slab. So, specific or unit weight. The specific weight of a fluid designated by the Greek symbol gamma is defined as its weight per unit volume. Okay? Thus, specific weight is related to density through this equation. So, this is the Greek letter gamma, Greek symbol gamma, equal to rho g. Greek letter rho times g. Ang g na yan ay acceleration due to gravity. Ang rho na yan ay density. Ang gamma ay specific weight. Okay? So, it is defined as weight over volume, weight per unit volume. So, sabihin niyan, ang specific weight gamma, bukod sa rho g, pwede rin siyang W over V, weight over volume. Yan. Okay, dalawa yan. Rho g or weight over volume ng substance. Okay? So, where Yung ating specific weight can be expressed in terms of Newton per cubic meter or pound per cubic foot. For water, take note, the specific weight is equals to 9.81 kilonewton per cubic meter at 0 degrees Celsius to 10 degrees Celsius. 62.4 pound force per cubic foot at 32 degree Fahrenheit to 60 degree Fahrenheit. No? 9.80 kilonewton per cubic meter at 60 degree Fahrenheit. 9.79 kilonewton per cubic meter at 20 degrees Celsius. Okay? So, yan yung mga specific weight nila ng tubig, no? Under conditions of standard gravity, okay, ang ating G value ay 32.174 feet per second squared or pwede na rin yung 32.2 feet per second squared, no? Or 9.81 meter per second squared. So, pwede na itong 32.2. Okay? Ayan. 32.2 feet per second squared. 9.81 meter per second squared. Okay? So, yan ang standard gravity natin. Okay? And then, specific gravity naman. When we talk about specific gravity of a fluid, designated by SG, no? Defined as the ratio of density of the fluid to the density of water. Okay? At some specified temperature. No? So in this case, ating formula natin, ating standard na ginagamit natin, density of water at 4 degrees Celsius. No? So, we have, so usually the specified temperature is taken at as 4 degrees Celsius. Yun ang standard. Okay? At 4 degrees Celsius, which is 39.2 degree Fahrenheit. And at this temperature, the density of water is 1.94 slugs per cubic foot or 1,000 kilograms per cubic meter. So in equation form, specific gravity is expressed as Sg equals to rho over rho of water at 4 degrees Celsius. So density over density. Density of one substance over density of water at 4 degrees Celsius. No? So, density of water at 4 degrees Celsius, take note, is 1.94 slug per cubic foot or 1,000 kilograms per cubic meter. Or the specific gravity can also be expressed in terms of the specific weight or unit weight. No? So, that is specific weight of a substance over the specific weight of water at 4 degrees Celsius. And the specific weight of water at 4 degrees Celsius is 62.4 pound force per cubic foot, 9.81 kilonewton per cubic meter, and that's it, no? So yun ang so that ends my discussion for part 1 of module 1. Alright, so in the next part, we'll answer some problems, no? So we can simplify this, no? Pwede na yung 32.2. Okay? Pwede standard na yan. Okay na yan. So that's it. So good day everyone.